Hi, my name is Sami Mujisha. I'm a data scientist specializing in building end-to-end machine learning solutions. Today, I'm excited to share with you this fantastic project, an AI-powered talent sourcing and candidate ranking system. I'll take you through the executive summary, the business problem, the exploratory data analysis, the text preprocessing techniques I used, the text vectorization methods used and the results, the deployment and the demo of the system. I'll take you through the tools used and skills demonstrated, and my future improvements and my conclusion remarks. So in summary, we've been able to develop a system that can identify and rank candidates effectively. The thing about this is that the rankings can actually be improved by human in the loop. So we tested different text embedding techniques and lexical models like Bagel words, term frequency, inverse document frequency. We used word embedding models like Word2Vec, Glove, and fast text. And we also used some contextual embedding models like BAT and SBAT. We ranked candidates according to their cosine similarity scores. The closer they are to 1, the better the model performed. SBAT and BAT consistently demonstrated superior performance because of their ability to capture semantics and the semantics relevance, the context in the different searches. Let's go. So the client was a talent sourcing and management company. They help other candidates find candidates to match different job titles. And this is really a very big challenge if you're in their position because one, you have to understand what the client wants in a potential candidate. You have to know what makes the candidate shine in the role that you're searching for. And you also know where to find these potential candidates. So it's a very difficult, talent sourcing is a very difficult area and very challenging and a very common challenge for any organization when you're dealing with a human resource. You would love a system that can automatically identify the best candidates for a role, rank them effectively for you, and improve rankings based on human feedback. And that's exactly what I'm going to show you how I have been able to solve this challenge. So I used a data set of 104 records. I have the job candidate ID, that's the candidate unique identifier, the job title for the candidate, the location where they're located, the number of connections they have, where for instance 500 plus means they have more than 500 connections, and the fit to the job, how the candidate fits to a particular role. So I began by doing some exploratory data analysis to find the relationships in the data, and quickly I could find that the most frequent words, the job titles were human resources related terms. There were some common modifiers like aspiring, profession, student. There are also education and business context, like for instance, college, universe, biz. All these were the different diversions in these job titles. This was confirmed by our word cloud here. As you can see, the human resource, aspiring, generalist profession are really the most dominant words in this data set. Most frequent locations, quickly as you can see, is greater North Carolina area, followed by the Houston and Texas areas. And this is where most of the candidates that applied were coming from. Most of the candidates were highly connected. They had more than 500 connections, which means we are dealing with a highly networked group. We checked this quorum fit, and unfortunately it was empty. It didn't have numbers, which means we don't have any ground truth to use to build any models. So we went ahead to do some data preprocessing and began with the connection column. It was initially a categorical variable, converted it to numeric. As you'll see later on, the connection has been used to break the tie where the candidates have similar rankings. The job title also standardized it for effective text vectorization. We did a number of text processing techniques, for instance, converting the text to lowercase, tokenization, regex for specific patterns, for instance, removing symbols, URLs, hashtags, etc. We did some stop word removal, eliminating words like are, the, is, and etc. We did some punctuation removal, for instance, the word engineer and the word engineer with a full stop should be treated the same, really. We did some Potter stemming, stemming words to the original stem. Words like aspiring were now stemmed to aspire. And we also join later the tokens to a string, combining cleaned and stemmed words back into a single string. These were the results. One with bag of words on this search term, aspiring human resources. These are top 10 candidates, 76 being the highest, up to 16. The similarity scores ranked from 0.35 to 0.40. I think the top 3 candidates have the same similarity score, and therefore the connection has been used to break the tie. So generally, as expected, bag of words doesn't capture the context, does counting of words, and that's why the similarity scores are quite very, very low. We later applied this term frequency inverse frequency document, which also was applied, and these were the top candidates. Also, similarity scores from 0.1 to 0.3. They are quite low. It's an improvement on the bag of words by down weighting the common words, but again, the results are not very good using this method. Later used word2vec. Now, because word2vec can capture the meanings in the words, the similarity scores have gone up. Remember that the scores that are nearest to 1 are considered the best. The cosine similarity is good, and this is what the results on this search term, aspiring human resources professionals. Top candidate being number 5, up to 32 here in the top 10. So a good improvement. And we later used Glove, which applies the global corpus to word2vec. And here now we can see that, for instance, words like specialist and professional are grouped together, while words like specialist and advisory board member even have negative similarity scores. So Glove really does a good job in capturing the meaning in the words, and as confirmed by these similarity scores. We later applied fast text. Fast text is very powerful, especially for out of vocabulary words, used for special text messages and other kind of sub-word information. This is what we got. Again, the rankings are here. The similarity scores as shown, ranging from 0.7, 0.83, quite good, because you can also capture some meaning in the words. We later applied BAT, the bidirectional encoder representations from transformers. This is where the transformers come in. Attention is all you need, and we see they rank from 5. The ranking is here 532 for the top 10, and the similarity scores going 0.9. Those are good scores, and we can see the top results are dominated by titles like aspiring human resources professional and aspiring human resources specialist, all with very high similarity scores, meaning that BAT was able to go down and capture the meanings and also get the context within the meanings. We later tried sentence BAT, again the similar terms, and better similarity scores now ranging from 0.92, 0.94, top candidate being 96 up to 35, showing that both generic BAT and SBAT still yield high relevant scores, and they are able to capture the semantics and the semantic relevance between the words and the sentences in this case. We tested BAT on this search term, full stack software engineer, and the scores were from 0.7, 0.74 as shown here, the rankings, candidate number 65 being the best. So here we see that BAT generated some of the results from this full software stack, but remember we had very information about this. Let's see what SBAT showed. Wow, SBAT actually dropped the rankings. SBAT was able to actually say, you know what, terms like human resource professional have very little connection to the term full software stack engineer. So SBAT again showing its power in understanding the context, especially within sentences. This violin graph quickly shows the performance of the different methods that we've talked about. SBAT and BAT having high and tightly coupled clusters with high similarity scores. Word2vec, Glove, and Fast having better but lower similarity than SBAT and BAT. And TF, IDF, and bag of words having very low, the lowest similarity scores and potential distributions, particularly for the TF IDF method. So when we compare really the different methods that we've talked about, bag of words and TF, IDF really do not capture the meaning and context in the words. Word2vec, Glove, and fast text capture meaning, but they don't capture the context, whereas BAT and SBAT capture both meaning and context, and that's why they are very powerful for use, especially for deep natural language processing techniques and similarity search the ones that, for instance, we are doing, especially on a sentence level, you would want to use SBAT. If we go to look at it, the application was Dockerized and deployed on the Hugging Face store. That's the URL where you can access it from. This is how it looks like. I'll load the ranking model. I used the TF IDF method because it ranks quite faster. It loads quick, it's fast. I couldn't load the SBAT model with the resources that I have on my server, but quickly we can have a quick demo of this, how this looks like. Yeah, we have such parameters here as per human resources. We have the weighting, simulator score here, and these are the top 10 candidates using this TF, term frequency, inverse document frequency. And as you can see, these are the scores. The simulator scores are here. These are top 10. I'm going to reset the rankings and start a candidate. I'm going to, for instance, candidate. Let me start candidate number 2. Right now, it's ranking from 76 to 57. Let's see if we start candidate number 2, what we will get. It now ranks 76 and the last one is 45. So starting a candidate actually improves the rankings, and the candidates are re-ranked again, and we can do this over and over again. Let's reset and try starting another candidate, maybe candidate number 96, and see how the model re-ranks and reorders the candidates. Again, you see there was some reordering here, and that's the power of human in the loop feedback to help improve the rankings and make them even much better. So we used a number of techniques to carry out this task. I used a lot of Python, NumPy, Scikit, used the natural language toolkit, the GenSim for word-to-vec and fast text, BAT and SBAT embeddings, Matchplotly for data visualization, Streamlit for building the interactive web application, Hugging Face Space for deploying the web application, etc. So there are many improvements that we can make to this work. First one being using advanced semantic models like large language models, fine-tune existing ones. These can actually yield even better results with a very good prompt engineering techniques. We can have more multimodal data integration, incorporating other data types beyond job titles. For instance, the job descriptions, etc. could help us yield even much better results. Personalizations, where we allow recruiters actually to improve rankings based on their peer success metrics, etc. And this also improves rankings greatly. We can apply some dynamic thresholds so that we adjust based on the query's complexity. And this also helps to really rank candidates better. We can add more descriptions in our UI so that the interface is explainable, and we explain what the AI is doing. So we can do more explainable features by explaining what contributes to what ranking and why some candidates are ranked higher than others. Of course, if we have larger data sets, we can actually do a better scalable solution and get better vector databases. And as well, if we have some ground truth in terms of the yeses and the nos, we can get better rankings and apply more machine learning models. So in summary, we have been able to build a full candidate ranking and sourcing application. You begin with the data sources, you process the data, you retrieve the candidates using SBAT embeddings, the best model that we found out. You do some reranking using the human in the loop. Then you get your top ranked candidates, and those can be visible on a web interface as we've shown, and you can later save your feedback and use the same model to continuously improve your ranking model. I hope you enjoyed this challenge and this project that I've carried on. If you would like me to build for a similar project for your HR department, I'm happy to share with you more on how I can do this. That's my LinkedIn address and that's my GitHub address. I hope you enjoy your day, and thank you very much.